Hello, Mario! In this video, I'm going to take a bit of a look at included angles and the hanging lines that, well, in my experience, these have usually been associated with. That's not to say they're always associated with hanging lines, but usually they are. So let's get on to the main scene here and see what we've got. So here we are in green. We have what we call a closed traverse, or this is what I've tried to indicate here. And it's a closed traverse. We're going from iron tube 1 to iron tube 2 to iron tube 3, round through a whole lot of marks and back to iron tube 1, and a closed mathematical traverse. So we've got a very good check on the values for those points because of the level of detail that we've done and measured, face left and face right, and all that sort of thing. So we can be quite certain that it all closes up good. And I've tried to give a bit of a representation here of the sort of readings, not all of them, but the readings you would get here with a closed traverse, and your reduced bearing here from iron tube 2 to iron tube 1, and from iron tube 2 to iron tube 3. Now, then in the New Zealand scene anyway, it comes to pass that we might put in a peg out here at either a known bearing and distance, or we may have put the peg in at a position we want to be the boundary and we've just picked it up. Now when we do that, we create what we call normally a hanging line, which is just a vector from one of these closed traverse points to the peg itself. Just a single vector with a bearing and distance, and usually that is not checked per se onto independently from anyone else. It's just we backsight at iron tube 2, we would backsight iron tube 1 of 1850630 and use that as our orientation to place our peg in on what we call a hanging line. Generally we keep these pretty short, or we have limits as to how long they can be in certain circumstances because of the error associated, or bearing error that could be associated with these. A small error could have quite a large effect. So once we've got our peg in on the correct orientation, we have this procedure or philosophy that hanging lines are to be measured and observed twice. It's a way of sort of giving a second check, or independently measuring and observing them from the same mark. And one of the ways that we can do this is with the included angle. Now, as you know, with bearings, we always measure our bearings clockwise from north. So we can measure the included angle by just setting 0 on the backside, in this case 1850630, and then measuring from there all the way round to peg 1 in the clockwise direction. And in this case, that will give us the included angle there, which is 3105430. 3105430, and that's the included angle. Now we can check that we add the included angle to 1850630. When we add them together, we should get 13601. That's one way of doing it. The way I do it is that I record in the first line over here, I record the face left bearing, or the true bearing. I then write the included angle underneath, 3105430, and I take that away there to make sure that I get back to the backside. Now, this sometimes they can get a little bit tricky, and this is one of the more trickier ones. Obviously, the 30 seconds will come away from there as 30, and we could carry one across. 55 from 01 is 06, and then we've got 311, but 1 away from 6 would be 5. Now we've got 301, 130 minus 310, and obviously that's a bit tricky to work out. What we can do is add 360 onto here, which makes no difference at all. But what I do is I can see that this is 310. It's obviously 50 degrees to get it round to 360. So So if I just add that, and then we go 136 degrees 01. So we just add the 50, and we can see that that comes out at 185.0630. Similarly, if we add these together, that will give us 0, 0 there, 01 there to 60. We've got a 6 there, and then we've got 180 is 490 minus 360 gives us 136.01. So that's the little check that I do. Give it the old 2 ticks just to show that I've checked it. Also, the other thing is we call these pegs hanging lines. So we independently check the distance as well. Number of ways of doing that. We could measure the distance in feet. I've chosen here just to use a cloth tape. We could measure in feet and inches. We could measure at different heights. We could measure it on the horizontal as opposed to on an angle. Number of different things. We can hold the tape on a even meter and read it back the other way. There's a variety of independent ways that we could just check the measurement. So this leads us to this little statement here. Hanging lines have been measured and observed twice. I usually like to include that in my survey report, and you will see that on some of the older imperial plans, proudly written there and signed by the surveyor or certified by the surveyor that hanging lines have been measured and observed twice. So there you have it, the included angle check, essentially just setting 0 on the back side and measuring around, and then just doing a small calculation there to make sure that everything's okay. Normally, if they're within a minute or so, that's fine. And just remember that these are a check. So the 136.01 is your accurate measurement of the bearing of 2 peg 01. The 310.5430, the included angle, and the subsequent calculation is just a check. So if they're a couple of minutes out, it's okay, as long as they're within tolerance. If, however, you do get a problem, it would then be necessary to, what I would do was reorientate on the back side and just check my bearing, face left bearing, 2 peg 01. Similarly with the distance. The measurement, first measurement here is the actual measurement you would use. It's just a check, so it just needs to be within 10 mils or so. So that concludes my little video on included angles and hanging lines.